Hey there everybody, welcome back to the channel. So on to the next problem in the list. I guess this is the ninth problem. This maybe is the 10th problem. Well, the pace for this is the ninth problem actually. So the pace is going very slowly. So I just have to catch up so that it will complete on the time. So probably I'll complete uh, as much as possible until we revamp the desired position according to the time. So let's leave it aside. The thing is, the lead code 3, the problem is lead code 304. It's a medium level problem, and the title is range sum query 2D immutable. Let's see what is it about. We have a 2D matrix named matrix. Handle multiple queries of the following type. Calculate the sum of elements of matrix inside the rectangle defined by its upper left corner, row 1 column 1, and the lower right column, row 2 column 2. Okay, implement the num matrix class. Okay, we have to implement this class where what num matrix will do is initializes the object with the integer matrix. Okay, this will store the matrix, and some region will do, it will take a row and column like the indexes, row 2 and column 2, return the sum of the elements of matrix inside the rectangle defined by its upper left corner. Sum of the elements of matrix inside the rectangle defined by its upper left corner, okay, and lower right corner. You must design an algorithm where some region works on order of one time complexity. Okay, this should be done in order of one time complexity. Let's see how this can be done. And the length of the matrix, the rows and columns will be between 1 and 200. Matrix values will be between minus 10 to the power of 4 and 10 to the power of 4. So at most, so row 1, row 2 and column 1, column 2 will be between 1 and 200, I guess. I mean 0 and 200. Not 200, 0 and 199, I guess. So at most 10 to the power of 4 calls will be made to some region. Okay, so everything is clearly given, but we have to, the challenging part is we have to design the algorithm such that each sum region will take up to 10 to the power, I mean order of one time. That means it should access the value and return it, not do any calculation. We have to think about it. So how can we do it? Let's see. For example, we'll take the what do we call it, the leftmost values will be same, 30142 5141, and we'll do one thing. And since it is a rectangle, we'll take the left rightmost corner, like 6 as the rightmost corner, and we'll do everything until that point. For example, 3 will be here and 0 and 5 will be here, right? So we'll add everything like 8 plus 6. 8 plus 6 will be 14, which will have this entire thing. Now if we have 14 here, if we are asked to find the this rectangle area, 14 minus 5 will be, it will be 9. For example, we'll have, let's consider this block 213, 314, so 7 plus 6 13 plus 8 will be 21 in total here. If I choose this block, that means we'll have, how how do we do it? We have to do some kind of calculation here. 0 0 let's see how many different combinations we can get for M and N. Can have 0 1 0 0 0 1 0 2 0 3 0 4 0 5 0 6. Let's try to see the topics. Prefix sum. So how can we do a prefix sum in a 2D matrix? Well, that's what we thought too, but I couldn't understand what way we can do it. Let's try this on this entire row. 3 3 4 8 10. If I was given with 3 and 1, we will have 8 here. Try to implement since we have seen the topic. Command equals to length of matrix and rows. So let's try to create a prefix matrix which will have 3 3 4 8 and 10 5 11 14 16 17. This is the matrix. Color looks good on it. So this is the matrix we'll have if we do the prefix sum for each row. And if I have to do a calculation from this point to this point, all we have to do is 8 plus 16 plus 4, that is 28. But it is not order of one time. It will take order of number of columns. And if we have to calculate this, we'll have to do 16 minus 5 plus 4 minus 1, which will be 11 plus 3, 14. Well, this will work fine, but it is not order of one time. Let's try checking like a 3D prefix, some type of thing. Let's see. So we'll have 0 3, 0 3, 0 4, 0 8, 10. Zero 5. Now 6 will have this entire square. That means 8 plus 6, 14. And this will have this entire square. Instead of doing this thing What if we do like we did it horizontally? Let's do it vertically too. Like 0, 3, 0, 4, and 0, 2, and 0, 8. That we have a vertical and horizontal prefix sums. What if we do like we'll have the row and column? For example, we'll have 6, so this one, and here the total sum will be 9, 11. Eight minus 0, 4 minus 1, 3, so 11, and 14 minus 5, 3 minus 1, 14 minus 5 will be 9, and 3 minus 1 will be 2, so the total will be 11 again. And if the timer hits 30 minutes and we cannot find anything, then we'll try to ask ChatGPT. If I have 0 0 and 2 2, the value will be 3 plus. It's a sum until this point, and this sum. If I take this point, which is 4 and 7, the total is 11. So 7, 8, 9, 10. So this total is 10 actually, but we have to minus this value because this will occur 2 times. I think I got an idea. But instead of 2, we need 3 such 3 such rows, 3 such matrices. The third matrix is square, like square additions. So 0 3. Five, 11. 11 plus 4 plus 1. 4 plus 9, 13. Sorry, 12 minus this common block. If I have to do a calculation like this, the sum of this block, then we'll take the minimal square, which will be this, and we'll add this portion to it, which is 19. This block is 19, and this vertical sum is 8. And if I have to do this calculation, and 6 and 0, this block, then what can I do? We take the minimum block, minimum square, which will be this one, and we can add this particular sum. But we cannot find this square. where by this point we'll have this entire square. Now to find this point, we have to remove this value. By here, if we have to find this block, we have this entire thing here, which make now we'll have to remove this entire thing and this thing. So the choices we have are a square, a minimal square, or a maximum square. If we have a minimum square, we'll add a row or column to it, or 2 rows or 3 rows. Let it hit the 30 seconds mark, I mean 30 minutes mark. So let's take the help of GPT 304. Help me with lead code 304. Yes. Okay. So squares. Mhm. To compute a carry from, let's see, we need the sum of smaller rectangles. Inclusion exclusion applies. B, C, and D. Okay, let's think this through. Since we got an answer, let's try to do this prefix. So 'rows and columns'. 0 to that point. Sum of all cells in rectangle. So 3, 0, 4, 8, 10, 8, 6 plus 8 will be, and by the time we'll reach here, we will have three, six, 6 after Go to the top, we do row minus 1. Go to the left, top left, 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 minus, top left. Current value equals to Okay. So zero column. Okay, fine. 3, 3, 4, 8, 10, 8, 8 plus 6, 14, 14 plus 4, 18, 18 plus 6, 24, 24 plus 3, 27. Okay. The prefix is properly cooked. Now to find the answer, now to find this sum, what we have is, we have this entire part and this entire part. So to find this part, what we have to do is, we have this whole thing and this whole thing. What we have to do is, we have to remove this part, and to do that, we'll do this minus this plus this value. So from this entire thing, we'll minus this and then this. We'll Center sum from the entire sum. What we need to do is row 1. Or else row. This is, for example, if we take this part, this is the whole. From this we have to remove this and this. So just above the row 1. Row 2, column 1. Row 1, column 1, row 2, column 2. We have to go to the upper row, so row 1 and to this part. Now this part will be row 2, column 1. Plus 1. For this, we take this point, we'll have this entire sum. If we do minus this, this upper corner extra top extra on the left. Top. Row 1, column 1. This is row 1, column 1. Row 1 minus 1, column minus 1. Okay. Now the whole minus extra top minus extra left plus the difference. Let's see. This worked out fine. Let's show this to the ChatGPT and take some review. What is meaningful for the correctness later? Okay. Since we are not doing minus 1 anywhere here, column minus 1, row minus 1, probably can return this. I mean, take this out. This is working fine. So A is the hole, I guess. The hole. B and C is extra top and extra left, I guess. And D is the double removed part. And same here. Top. And this is left. Top plus left minus the top left one plus the matrix value. So top plus left minus top left plus current value. Okay, well, this is working, like this is looking good. So let me submit this. Well, this worked out fine, but probably there seems to be better approaches. If I is not 0, well, we are skipping it directly. Took 107 milliseconds to complete and 71 milliseconds for this. So the top, the left, and the top left total sum minus top minus left plus top left. Is it because it has one less row and column? Maybe. Let's try that too. And if it proves to be computationally expensive, then we learn something new. n into m in the extra padded part in the prefix cause time complexity. Something already maintained in the wrong below perspective. Constructing m into n. This m plus n. For well, that's it, guys. I hope you guys understood the intuition. If you want, let me explain this part again. What we are doing is from the prefix we have the padded part. So starting from 1, I minus 1 always gives 0 in the worst case, and m minus 1 in the m 0 to m minus 1, which is the length of the matrix. So I minus 1 j minus 1 will always be in the range of the matrix. So what we are doing is, for example, if we take this block, we have already this part computed previously and this part computed previously. So what we are doing is we need to compute this whole part, for which what we are doing, we are adding this part to 3. Now we have this thing right here and adding this part to 3, which will give us this whole thing. But since we have calculated this part already, from here let's remove this part, for which what we'll do, we remove this part from this top left. So we add this, and we remove the top left. And you might think why we go that, like why should we do that? We can do this, right? So something like adding this thing and taking this one value instead of adding and removing all of this. But see, from this perspective, if we are here at 1, this whole sum, let's see, we need this entire part, right? So what we should do, this will have this entire thing calculated, but we cannot simply add this one value to this whole, which leaves 4. So we have to do this entire thing, for which we'll take this entire value and this entire value. Since this is the duplicate or the overlapped value, we'll remove, actually this whole thing is the overlapped value, so we'll remove this value. So this plus this minus this. So the double calculation is removed, which gives this entire thing. And same goes here again. From the calculated prefix, what we are doing is we are taking the whole, so the whole sum. For example, if we take this point, this is the whole sum, from which we have to remove, like if this is the point until which we have to calculate, what we are doing is we are taking this whole and removing this part and removing this part. But if you observe anything, what we are doing is we are removing this and this, which gives this duplicate removal again. So double minus, here double negative is happening, which will cause a negative impact. So to cancel out this double negativity, we are taking this cross value and we are adding it. So the top left is added, whereas the top and left parts are removed from the whole. So that's it, guys. I hope you guys understood the intuition. If you like the video, upvote it and share it with your friends, and don't forget to subscribe to the channel. We'll meet you again with another video. Until then, keep learning and keep pushing hard. Let's see how much time it took for us to complete this problem. It took 1 hour 24 minutes. So also just leave a comment and we'll check your doubts and we'll address your doubts, and we'll have a better reach if you give us a thumbs up and do something, a good comment, like you like the video or it is insightful, something like that. It would be helpful. So thank you for choosing the channel. Goodbye, guys.